class recording has started. So, first order of business for today. Calendar. On Friday, we started in on the stoichiometry idea, and that started getting us into relating different parts of the equation, but talking about numbers, and we'll review that a little bit more as we go along today, and we'll expand on that a little bit more today with a new kind of problem. So, beginning of the period, we took a quiz, new kind of stoichiometry problem today. Then on Thursday, we will continue on with the stoichiometry idea. There's one other kind of problem that we'll talk about, and we'll handle that on Thursday. Then most of Thursday we will spend dealing with the magnesium oxide lab. The magnesium oxide lab introduces two new concepts in stoichiometry, limiting reactant and percent yield. We're not going to get into those too deeply, we're just going to kind of introduce them to you. But we'll spend a lot of Friday actually doing calculations and follow-up from the lab that we're going to collect data for on Thursday. Also on Friday, next quiz over the stoichiometry calculations that we started in on Friday, continued today, and then we will continue on Thursday. Next week, couple things to wrap up chemical reactions. First, neutralization reactions on Monday. Second, reaction rates on Tuesday. So we'll deal with those things pretty briefly on Monday and Tuesday. Then lab next week is probably going to introduce us to the next unit. Won't be related to chemical reaction stuff. But then your test over chemical reactions is on next Friday, February 1st. Okay? Questions there?
Is the quiz like the intro to stoichiometry? Is that OpenO?
Yeah, it's OpenO quiz, yes. So, yes.
Are we doing the lab report for this lab?
I haven't decided yet 100%, but I'm kind of leaning that way to get that done, to get your lab report out of the way early this grading period. So, okay. Yes, Kate?
And when would it be due?
Probably not until like the following week, like Friday maybe, because they're going to introduce a couple concepts that make sure they will relate to that lab on Monday and Tuesday. So that's I kind of have to work that out, Katie, but it probably would be like at least a week afterwards. So, okay. All right, good there? Okay. On Friday, we introduced the idea of stoichiometry. And we said, like the definition says, stoichiometry are mass and quantity relationships among reactants and products. And we said that stoichiometry is quantitative, where now we're starting to look at numbers involved in a chemical reaction. And we said there was one really important factor that allows us to compare one part of the equation to another part of the equation. How can we compare one part of the equation to another part of the equation? What do we have to have in order to do that? Right? Coefficients from a balanced equation. Right? We kind of talked about the idea that this equation represents the what is happening. We kind of said that would be like if you had a recipe, but it didn't have any amounts on it. It just said, hey, you need eggs and milk and butter and flour and sugar, but it didn't say how much of those things you needed. Here, when we put the coefficients in there, now we start talking about the relative amounts of those things. You need 1 cup of flour and 1 cup of sugar and whatever. Okay? Good there? On the back of your outline that I gave you Friday, there is this flow chart. It's in the bottom right-hand corner. That flow chart runs you through all different kinds of stoichiometry problems, at least the basic ones. On Friday, we started off with the most basic kind of stoichiometry problem, and that was a mole-to-mole ratio. So let me grab this here. Let me go here. Do this. Okay. So this flowchart says start here, end here, depending on what you want. We did this on Friday. We started off with a substance in moles, and then we used a very important conversion factor called the mole ratio to compare one part of the moles, or one set of moles, to another set of moles. And then we ended with an answer in moles, which is great. concept of the mole ratio and compares one part of the equation to another part of the equation. But anybody here measure things in moles really often? All the time, right? I have my mole balance at home. I just, anyway. It's not generally how we measure things, but that doesn't mean that we can't compare them to one another. So that leads us to the second kind of problem that we're going to do, and that is the mass-mole relationship. Which is on the back of your outline. It's Roman numeral number 3, and it's letter A underneath Roman numeral number 3. It says, when magnesium burns in air, a combustion reaction produces solid magnesium oxide. How many grams of magnesium oxide will be produced from 2.00 moles of magnesium? So, first things first, steps to solving stoichiometry problems. There's one thing we have to do first before we get into the comparing different parts. And if you flip over your outline to the first side, there's a steps to solving stoichiometry problems. And what's the first step to solving a stoichiometry problem? What do we have to do? Write a balanced equation. This gives you a description in words of a chemical reaction. I want you to first, when you're 2 or 3 person little groups, to come up with a equation, a balanced equation that represents that reaction. Ready? Go. Let's see if we can get this done in 2 minutes. A balanced equation to represent that reaction in yellow. Go.
What's air? Is it O2? Pretty sure it's O2. Might be wrong. What is air?
Periodic table.
The air isn't the important part of that description.
Well, it's Mg to helpful.
No. It tells you what kind of a reaction is occurring in that description.
Oh.
Should point you in a certain direction.
Well, thanks a lot.
Combustion except then reaction with O2. What other reaction?
What?
Yeah, I know.
So it's MgO2 equals.
So see, oxygen has 6 valence electrons, right? Magnesium has 1. I'm not looking at a periodic table right now. What? Where's magnesium? It has 2. Okay, so it's just MgO2. And you put a 2 on the side.
That has 2.
I think it's
So MgO2 and then 2.
Is it this or is it? Yeah.
No, there's. Oh, you're making. Oh, it's not 1. It's 2 different.
What is it?
It's Mg plus O2. And then 2 Mg. I don't know. Is that right?
Magnesium losing 2 valence electrons. It needs 2 valence electrons. Alright, so I know you guys might not be done, but that's okay. I will help you through it because I want to get through this here and make sure we get through the whole thing. Alright, so first, a chemical equation tells us what? What does a chemical equation do for us? Tells us
I'm pretty sure it's
Sorry,
something
what
like
is
that.
reacting?
we call those tells you the reactants, right? So what's one reactant of this equation?
Magnesium.
Magnesium is one reaction, right? Or reactant, right? So it's Mg plus. Now here's the tricky part, right? What kind of a reaction does it say is happening here?
Combustion.
Combustion, right? A combustion reaction. Maddie, what's a requirement for something to be a combustion reaction? It has to mix with oxygen, right? These are my reactants in this reaction. Okay? What is it making? Produces solid magnesium oxide. That means magnesium oxide is what? The product of this reaction. And based on where it is on the periodic table, where magnesium is, where oxygen is, that's the formula for magnesium oxide. Okay? Does that make sense? Will you have to do that on a test? No. But that's a good review to make sure we know types of chemical reactions and stuff like that. Okay? On a test, I'll give you this equation. You're going to have to balance it, though. Is this a balanced chemical equation? Not. It's pretty easy to balance, though. All right. Good there?
Yep.
Now, let's do what this problem asks us for, right? So it says how many grams of magnesium oxide would be produced from 2 moles of magnesium? Stoichiometry problems are conversion factor problems. So when you start a conversion factor problem, you start off with what was given to you, right? What did they give us to start with in this problem?
2 moles.
2 moles of magnesium, right? So 2.00 moles of magnesium. It's really kind of important that you keep the formulas there along with the units. Okay? So, next step. What's the next step? Time sign, fraction bar. What unit has to go on the bottom of this conversion factor? Specific moles of magnesium. Okay? Now, don't write the next thing down just yet. Based on everything that you know about conversion factors at this point in time, what should go on the top of that conversion factor? Grams of magnesium oxide. Logically, that's what the conversion factor does. It gets rid of one thing and tells you something else. And based on everything you know so far, that's what the conversion factor would be. But guess what? That's not how you do this problem. Because we have 2 different formulas here. What made a mole special? What's special about a mole? Do we remember? Max, was that a hand or was that a...
It's equal to the formula.
Yes, although that's sort of a coincidence. What was our definition of a mole? What'd you say?
It's a counting.
It's a counting thing, right? So whenever we have a mole of something, we have the same number of things, right? When we talk about these coefficients, right, they are giving us telling us the number of this atom to the number of that atom. Grams gives you a mass of that specific amount of stuff. If I have 1 mole of something and I have 1 mole of something else, is that the same thing? It's the same number of things, it's the same quantity of things, but if I put them on the balance, would they weigh the same? No. If I had 100 grams of something and 100 grams of something else, is that the same thing? It's the same mass, but is it the same number of stuff? No. This equation, balanced equation, gives you a ratio between the number of molecules or the number of atoms in the reactants and the number of atoms or the number of molecules in the products. You can't compare grams of something to grams of something when you're dealing with stoichiometries. It's not the same number of things. But you can compare moles of something to moles of something else. That being said, can I go from moles of magnesium to grams of magnesium oxide? Can't do that in one step. It's not an apples to apples comparison. But what could I put on the top of that conversion factor? Cookies.
Moles, magnesium oxide?
I could put moles of magnesium oxide on the top. Is that an apples to apples comparison? Yes. We gave this conversion factor a special name on Friday. Remember what we called that conversion factor? is the mole ratio. And where do we get the numbers from to make our mole ratio? Okay,
The coefficients.
the coefficients. So if we look at our equation here, right? Coefficient in front of magnesium oxide is 2. Coefficient in front of magnesium is 2 as well. That should be a pretty easy calculation for us, yes? And so we end up with 2.00 moles of magnesium oxide. Good there? Is that the end of our problem? No. This problem wanted how many grams of magnesium oxide. So, what are we going to do? Time sign fraction bar. What unit has to go on the bottom of that conversion factor? Moles of magnesium oxide has to go here because we're trying to get rid of it. Now, what unit can go on the top of that conversion factor? Grams of magnesium oxide. Is that okay? That's okay, right? Why? Because it's what?
Same thing.
It's the same formula, right? It's the same compound. Okay? When we're dealing this, with this conversion factor, what number goes in front of moles? 1. What number goes in front of grams? The formula mass. Where do we get the formula mass from? Alright. Add up the average time mass of all the things in the formula. Alright. Then you run that through your calculator, you get 80.62. Is that your final answer? No. In this original measurement here, right, how many significant digits in 2.00? 3. So, significant, is that 0 significant? Yeah, why? Sandwiched, right? And then this is significant, chop it off there. 80.6 grams of magnesium oxide.
So we use the mole. So we use mole ratio when we don't have.
No, this is a good. Hey, wait. 2 more things I want to talk about. This is a good question. So, go ahead, Becca. You use the mole-to-mole ratio when you're comparing what?
When you have to get the same, I don't know how to explain it. When it's not apples to apples, but they are different.
When you're comparing one part of the equation to something else, right?
Yeah, that.
Okay.
What I meant.
Now, hey, stop, freeze for a second. I know the bell's about to ring in a minute, but I got to talk about this, okay? Because it's important, because I know some of you are going to do it.
Sorry.
Somebody earlier on asked this question. Freeze. Freeze. Somebody earlier on asked this question. Somebody asked me, shouldn't that be 2? Do you know why they asked, shouldn't that be 2?
Because it's in the equation in the top.
Because in the equation up the top, what number comes in front of magnesium oxide? 2. But here, right, we're comparing this on a 1 mole basis going from moles to grams, right? Now, 2's only come from the coefficients for comparing moles to moles and mole ratio, right? That sheet that I gave you today